I've had many people ask me, what can the QC motor generator really do? What's the peak output of this device? Can I run things in my home? Will it help me get off the grid? All these are the right questions, but what I really need to do is explain to you how the technology is working. I told you before, I believe in one of my previous videos, that the coil sets, there is 12 pounds of copper. 12 coils, each one's about a pound weight each. There's 12 pounds of copper that power has to go through and be pulsed simultaneously. All 12 coils pulse exactly the same time. This is the ultimate pulse motor, and I think this is going to set the standard by which all future pulse motors are going to operate, and I'm going to explain to you why. Now here I've just borrowed from the Quanta Hybrid the axial flux generator. The two magnetic rotors here are actually the magnetic coupling for the rotoverter, but they worked out fine for this. But as you can see, on each rotor there's 4 layers of magnets, 2 layers of N52s and 2 layers of N42s. So we're talking about some serious lines of flux cutting through those coils to generate some pretty incredible power. This thing will run and run and run on very little power because the coil sets are independent circuits, and they accumulate electromagnetic energy until they reach a point of saturation, and at which point the demand for amperage plummets by a factor of 10. So if you started running this thing at let's say 1 amp in the time that it takes to load these coils up to the point where they're fully saturated with electromagnetic flux energy, then it's going to drop from 1 amp down to 100 milliamps, and it'll run at 100 milliamps and still run at the same RPM and still give you the same torque for outputting power from the axial flux generator or whatever you've got connected to this. I just did this as a test just to show some examples of the capability. Now the interesting thing about this is that I think you'll find very interesting is the powering device. Let me come over here and show you, and there it is. That little thing. 1 9-volt battery. Let's see if you can get the glare off of this. 9.16 volts, and it's running the machine. Now obviously this is not under load at this time except for whatever I'm dumping in this flash cap. It's a 330 volt 450 microfarad flash cap, and it's just about 25 volts from the little 9-volt battery. But you say, well, what about the amperage? What are we doing with that? Let me just connect the camera here to the tripod. Yeah, I'm pretty jumpy here. Okay, here's the amperage draw from the 9-volt battery, and it's pretty much, well, it's pretty much 0. So we're talking about microamps, and yet microamps involved from 9.14 volts over here to nearly 25 volts over here, and it will power load. Yesterday I used another one of these Duracell 9 volts, and I ran it for about an hour and fully charged these two 6-volt lead acid lantern batteries. Brought them up to full charge, which was about 6.6 volts each. They're connected in series now because I'm going to show you how this little battery will charge those big batteries. Okay, we're connecting up now, except for the positive lead here, because I just wanted to show you what the battery voltage is of these two little lead acid batteries in series. It's 12.88 volts. With 12 pounds of copper having to be loaded up from that one little 9-volt battery and operate 11 pounds of rotor weight. We're talking about stainless steel, aluminum, polycarbonate, neodymium magnets, 11 pounds of mass, and 12 pounds of copper to do the work from that one little battery, and it'll power it for nearly 2 days? That's just unheard of. Well, it's because of this. Because of the amp draw. It's microamps. It reads 0. And yet, we can fully charge up some other batteries? Okay, let's do that. Make the connection. Now we're up to 1291.